Alright, so today I want to start actually looking at using this LCD display for a project. This is a color LCD display from a Gameboy Advance, or I'm sorry, Gameboy Advance, that I had actually put a backlit screen into for a buddy of mine at work. Now, sorry, I don't know how well this camera is going to be able to pick it up, but you can see that there are 3 chips on it. Here, let me get a pointer. There's a chip here, a chip there, and a chip there. So this is called a chip on glass style LCD because this chip is actually on the LCD glass. The ribbon connector is a double-sided ribbon connector as far as the traces go, and then it terminates on a single side with that many pins. So what I want to do is actually bring this under the microscope and start trying to figure out what these traces are. My guess is the chips here are multiplexed to drive individually, or to drive rather individual sections of the screen. Most likely this controls a vertical column or vertical row as it moves down, and then these 2 chips drive individual halves of the screen. But let's see if we can figure out the pinouts. First, I want to find the power rails. If I find the power rails, I can always play around with the capacitance value of my body by rubbing these pins and seeing what lights up on the display. So let's get into the microscope and see what we have. Alright, well, we're just going to deal with the screen being bright. Alright, so here are the chips. This is the lower right chip. No markings on it at all. But well, alright, you can't see the traces yet. I'll bring it in for that. Here's the bottom left chip, and this is what I suspect is the row driver. So let's go ahead and come in on it a little bit. It's actually kind of neat. You can start to see the individual pixels and how they break up into red, green, and blue. Or red, yellow, and blue, I'm sorry. There you go. Straighten the camera here. Alright. But that's not what we're here for. What we want to see yeah, that looks pretty clear. Let me turn the game back up. Alright, yeah, that looks good. So here you're starting to get an idea. You can see all of these traces that go into the chip, and a lot of smaller traces coming out the top. Let's see what's on the other side. Oh, this is going to be real helpful. Okay, so you can actually see. Oh, wow. Okay, if you're looking at this through the camera, you're not seeing anything. Alright. Alright, so what we have here is underneath one of the chips. And what's nice about this is you can actually see all of the pins that they've bonded to the glass and where they open up. Let me get my angle right. Wow, this is a very small angle, so I'm gonna make this count. Alright, so this is what I was saying about the pins. You can see all of these along here which come off the flat flex. And perhaps if I go in more, hold very still, you can see the pins up in the middle of the screen on top of the array here. You can see how they actually open up to the individual channels going up to the LCD. That's going to be harder for me to show you long term though, so I'm going to try not to put a whole lot of emphasis on that. Let me get my game back up. Alright, so what we want to do now is we'll probably start off by finding the ground plane, because why is everything so much brighter on the camera than it is in the lens? Holy mackerel. Alright, let's try this. Alright, yeah, there's going to be a lot of glare. But the reason that I want to start with the ground plane, or the ground pins rather, is because of these here. Notice these large fill zones, and they're on the other side too. Got this right here, this up here. Looks like this is the side here where the flat flex actually goes in, versus the other side which does not have anything useful there. So let's get started on trying to backtrace all of this. What I want to do is find a ground plane that goes to a pin. Like this one right here. Oh, that's useful. Alright, let me zoom in and turn down the exposure again. Get my pointer in. I know it's blurry, but this is the best angle I can get for you. Where's my pointer tool? There it is. You see this line that runs right along here? And you see how there's one trace that actually connects through to it, going down and back this way? That trace connects to, get it in shot here, this ground plane. Find it, to this ground plane right here. And I'm confident this is a ground plane. It might not be, but I'm pretty confident it is. So now let's take that logic and apply it to one of the other chips. Say this one here. So, oh, there it is right there. You can see right here, this pin connects through to that ground line, or what I suspect is a ground line. I'll get you a better light angle. There you go, you see how it connects? So now I'm just going to go ahead and follow that. Oops, I dropped it. I dropped it. Hey, wouldn't you know it? Terminates here on this ground plane. Okay, so now we have a logical system to use for finding the ground planes. Let's try and apply that system for this chip up here, which is going to be difficult, of course. Oh wow, these are actually turning up better on this chip than they did on the other ones. So I suspect that once again, actually, which one was it over here? It was a layer it was a layer going closest to the actual breakout pins. So I suspect that let's have a good clear shot, clear enough. I suspect that this run right here is going to be ground. So let me follow that. Ah, damn it. Metal shield in the way. Okay. This just got harder for all of us now. Don't feel bad. This just got a lot harder. You're just going to take my word for it, because unfortunately, what I'm actually trying to pick up here on the scope is a very faint difference in glass color where they ran the traces. I wish I could offer you something more than that. I really do. Unfortunately, well, you can actually kind of see it now, but it's very faint. You have to get the light just right, even in your live vision. All right, so let me follow this trace around. Opens up to here, and is this getting it? Oh wow, it is getting it. First try. You see how it connects to those 3 pins? So let's find out where those pins go. Where's my pointer? There it is. Could it be that easy? I doubt it. Alright, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 are the pins we're looking for. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's 12, 13, and 14 here. We go down, they all connect into or combine into one trace, which goes down to this via here. So from this corner, there's 3 vias, and then the via we're looking for. So over to that corner, there's 3 vias, and then the via we're. Seriously? Fine. Whatever. I'm not mad. This via here, and this one breaks out to a pin. I wonder then, that might not be a power. That might not be a ground. That might be an actual power pin then, because that one goes straight to the connector. Okay. So that is a traced out line. That goes to a major rail on the vertical chip. The vertical row select is what I assume it is. Okay. Let's go ahead and follow through on the other one then. So we're going to go back over here to the vertical chip. So there were two planes, if you recall. One at the top of the chip, one at the bottom. Let's follow the one at the bottom, which goes along to here. And let me get the light right. And it opens up to all three of the first pins, which do something back here. Combine into a connector. Go down to a via. And this is pin 4. Let's follow some of these data lines then. Because it might just be one side of the actual connector is driving the one chip, which would make the circuit a lot easier. So we remember that this was one that we traced out, and this is one that we had traced out. This looks like a ground plane, doesn't it? And I bet yep, the via opens right here in this ground plane. Oh wait, no, it doesn't. No, it doesn't. That's not the right via, is it? Hold on. Hold on. No, yeah, it does. This via right here. So we did find ground for the vertical chip then. Ground is not what I would have thought it is though. Ground is actually pins 4 and 5 and oh, hold up. Is that a tear? Oh no, this project might have just gotten trashed before it even started, guys. We got a tear in our ribbon. Alright, I'm gonna stop it here real quick. Alright, I've had a little bit of time to think about how I want to approach this. So the problem with used LCD screens, these flat flex cables got pressed into whatever application it was put into, which means that this copper sheet here has started to work harden, which makes it brittle. You combine that with the plastic, which also becomes brittle, and you're going to get these splits. Now, I can fix this pretty easily. I'll just run mod wires across it and then epoxy it or hot glue it or something. But before I do that, this is just going to get worse as I work. So what I want to do is at least identify the power rails before I go to fix it. What sucks is it seems to have broken this entire trace here on the side. So that's going to be a bit of a nuisance. That's pin 4 on the connector. Probably ground. Although, no, it might not be actually, because I don't think that actually terminates with ground. It doesn't share any of the ground planes, so it might not be. Alright, I'm going to go back to following these out, including the data lines, to get an idea of what we're working with here. Yeah, we'll just get back to it, I guess. Alright, so here's what I have identified. All of these ground planes are connected together, and they all go into pin 6 from the edge. But I think that there's actually another pin that shares with them. Which is this one here, pin 1, going all the way up to here, where it then cuts across all of the pins. Now I can't find where, if anywhere, this pin actually terminates in the ground plane. Yeah, because it seems to completely miss the ground plane every via that it has. But when you actually go to continuity mode on your multimeter, go bring the connector in sight here. So we want to go to 1, 2, 3, 4, 5, 6, I think. Was it 6 or 7? I think it was 6. And then the last one. So these two are continuous. So I need to figure out why. Why are they continuous? How are they continuous? Better yet. Okay, I have completely traced this line out, and it does not actually connect with the ground planes on the flat flex. So what that tells me is it's connecting the ground through the chips. Okay, the very first pin on the connector does not go to the vertical chip at all. But it does common together the bottom chips. Now I'm going to try and get this angle right for you to see. What is known about this, get my pointer in here, this thing here and this one over here do not go anywhere. They kind of terminate on themselves right down here. You can see how these four loop together. But we go back up here. This next one right here goes down and terminates over yonder. The next one in, which is this one right here. Oh wait, hold on, let me show you. So it's this one right here. Those two join together and come down here to that trace for pin 1. Now if we go with that same chip, I'm going to make this visible for you. Unfortunately, it's not easy. Go all the way over to this other side and get the light just right. We see the same thing. This outermost pin here goes off to somewhere. This one connects to that trace. And on the other way, or sorry, on the other chip, it's again the same thing. This buggers off to somewhere. This connects to that trace. Oh, you really can't see it that well. Why is this so difficult? I just take my word for it. And then on the other side, we've got a little bit of the same thing going on again. We've got zero chance of the light cooperating. Because, you know, why would it? Alright, so once again, we've got this issue with this very last, or the same issue with this very last piece over here not connecting to anything. This piece here, I believe, terminates in the same way. Yep, those all terminate together. Then we've got this piece here, which buggers off to somewhere, and this one connecting the trace. So notice that it's never quite the inside, or I'm sorry, the outermost pins that connect to that trace. It's the second ones in. I want to run with that for a minute. We'll stop the video here and go ahead and archive it to continue this project later.